Now we come across another method of solving differential equations, which is called Legendre differential equations. In this, we have an equation ax plus b is to the power n, and then we have the power of the differential and the power of this variable equation should be same as ax plus b whole power n and dny over dx square. If we have a power of this thing equals to n minus 1, then we also should have a power of, for the differential n minus 1. For example, ax plus b power n dny over dxn plus ax plus b n minus 1 d to the power n minus 1 y upon dxn minus 1. For example, if we have d2y and dx square, then our value of n equals to 2, and then if we have n equals to 1, then this is ax plus b. In this we have to let ax plus b, this thing can be solved without letting equals to e to the power z. Then z turns out to be z equals to log ax plus b. We take out the first derivative of this ax plus b. If we have this power, if we have the power of ax plus b equals to 1, then we have dy, and if we have this power equals to square, then we have d minus 1, and this follows as it is. If we have power of ax plus b equals to 3, like ax, if we have a power ax plus b to the power 3, then we have d minus 1, d minus 2, a to the power q. That's how it follows. And then, so equation 1 will become ax plus b and d and y over dx1 plus a and d minus 1 y, and then it follows as the rules. Now we can have an example on this legendary differential equations. Let's look at an example of this. Let's have a look. Let's say we have an equation 1 plus x square d square y over dx square. First we have to decide whether this is a Legendre equation or a Cauchy equation. To decide this, we should know that if there is a single variable here, like x square d square y over dx plus x dy over dx, then this is a Cauchy equation, not a Legendre equation. To be a Legendre equation, it needs to have 1 plus x, or equation which consists of both variables and constants. Only variable containing equation is not a Legendre equation, it is a Cauchy equation. So now we have a question 1 plus x square d square y over dx square plus 1 plus x dy over dx plus y equals to sine 2 log 1 plus x. First, we take, as we know from the before, we did in the formula, that first of all we let this thing 1 plus x equals to e raised to the power z, and then we make z the subject, which is z equals to log 1 plus x. Now this things equals this, so in place of this we can replace sine 2z. We will carry this forward in other steps. Let's have a look. 1 plus x, as told before, that which equals 1 plus x divided over dx equals dy, and similarly 1 plus x square d square y over dx square equals d minus 1 y. And then now we replace these two things with dy and d bracket open d minus y d minus 1 y. Let's have a look. We replace this thing by this, as shown here, d minus 1 y plus dy plus y. Y was already in this equation, equals to sine 2z. Sine 2z we got it from here, as shown. Okay, then we solve this equation, and we got d square minus d plus 1 bracket close y equals to sine 2z. This d cancel out with this d, and then we have final equation d square plus 1 bracket y equals to sine 2z. Now we solve for d square plus 1 to calculate our yc. To calculate our yc, we equal yc equals to d square plus 1, and d square plus 1 is equals to 0. Then d square equals to minus 1, and our roots turns out to be plus minus iota, which is written over here, plus minus iota. This plus minus iota has a certain form of showing how we write yc. So we write yc equals to e raised to the power of constant x plus a cos iota x plus b sine iota x, which is written over here. Let's say we have roots m equals to plus minus iota. We write it in the form yc equals to a cos z plus b sine z. This is the equation of yc. Now we calculate the equation of yp. For yp, we divide the equation d square plus 1 sine, we make the y subject. Y equals to sine 2z divided by d square plus 1, which is written over here. Then in place of d, we replace 2. Let's say if this 2 is a, then at the place of d, we replace d squared equals to minus a squared as written over here. So we replace minus 2 power square plus 1. So we have minus 1 over 3 sine 2z. This turns out to be our yp. One more thing. If this thing, the denominator of this equation turns out to be 0, then we derivate this whole equation again and solve for yp in the same sense. And again, if it turns out to be 0, then we take a third differential and solve for this it again. This is yp and this is yc. And then we have y equals to yc plus yp, which is the final equation of this question.